you go, if I had to find like the average value of a function, I'll just write f(ab) between two values like a and b, and these are just two numbers. You know, a is like, let's say a was 2, and the b value is 5. And I need you to find the average value of the function f from x equals 2 to x equals 5. So you don't even have to think of these as a's and b's. Does anybody know the math formula on how to find the average value of the function between those?
Wouldn't it be like f of b minus f of a over 5 minus 2?
He just nailed it. So when he's doing slope, he just nailed it. That was perfect. And good job. He just did slope. So if he had to find the average value between the value b and a, he goes, he'd get f of a, you'd subtract f of a over b minus a. But you notice that's just slope?
Yeah.
That's just, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1 for two x, y coordinates. So now you're like, oh, now I see y in 2.1, which the author titles the tangent and velocity problems. We're just finding the what? Average value of a function or slope. That's all we're finding. We're finding what's the average value of a function. The average value of the function. And we're like, okay, we don't have to do 100 of these, do we? Well, let's do one, right? And let's do one that has like an A and a B and a C and D. And we'll do it together. That sound good? Alright. I'm going to erase this. This is all we have to do, huh? F of B minus f of A over B minus A. That's how you find the average value of a function. Sound good? The average, and I should be clear when I say this. Not the average really value. Would you write this down? This is what I mean by it. The average rate of change is what I'm hitting on of a function. The average rate of change of a function f of x, the math formula is do f of b minus f of a all over b minus a. That's all we have to do. In other words, slope. So I'm sorry when I wrote function's average value. We'll get to that later in the course. I'm talking about the average rate of change of the function f of x. So on average, how did it change? And we'll do that. Well, hey, so to make this simple to us, this is slope, right? Average rate of change of a function. Let's just do temperature, and then we'll get a sense of this. Remember when at 6 a.m., it was 50 degrees Fahrenheit. 5 hours later, it's 11 a.m. It was 65 degrees Fahrenheit. All right? And my question for you, it's a math question. Can you find the average rate of change of the temperature over that time period? And you're like, yeah, I can do it. And how do you do it? Well, right here. This is all you do. Can you find the average rate of change? The temperature went up, didn't it? But how, on average, how did it go up per hour? And so what can you do? Well, I can think of this as an x and a y, and this is an x and a y, right? It's always good in math to make time x. So, all right, here's my x, there's my y. There's my x, there's my y. I'll put subscripts of 1s here. X sub 1, y sub 1. This is x sub 2, y sub 2. Can you find the average rate of change of the temperature during that time period? And you're like, yeah, no problem. Right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? That's all we'll do. You might be able to do it in your head. What's 65 minus 50? 15. And then here comes time. 11 minus the what? 6. So I get 15 degrees Fahrenheit per how many hours? Now do you want to simplify that answer?
Yeah.
What could you say? On average, the temperature changed how many degrees per hour? There you go. You can just put an HR at the bottom. You just want to put an H. On average, the temperature increased 3 degrees per hour. Did it do that each hour perfectly? No, it probably went up like 1 hour, 1 degree Fahrenheit the first time, and then went up even quicker in the second hour. But on average, what happened between those two, between the 6 a.m. and 11 a.m.? So everyone, pretty easy concept, all right? So like, okay, got it. Well, let's do one problem. Let's do that number 5. Yeah, started to steal the thunder from the problem that I put in the syllabus, but let's do it. Let's do this problem. This is number 5. All right, and what they got here? They got a little math formula. They got y equals. Hey, is anyone want the actual page number? This is on page 86. Someone might not have the textbook. Everyone, I could have chosen 7. I could have chosen 3. I just like 5 because they're throwing a ball. And they throw a ball, and they said it's thrown with an initial velocity of 40 feet per second. And they go, here's the height at time t. So this is the height at time t. Y equals 40t minus 16t squared. So when y is your height, position, t is your time, and this is in seconds. All right, and that represents the position, the actual height of the ball. If a ball is thrown into the air, so the ball gets thrown into the air, it's thrown from the ground, and when that actually deals with the gravitational pull in the earth, that negative 16 right there. Then what you think was thrown off the planet, or another planet, or like the moon. All right, so what they want us to do in this problem, here we go. They said find the average velocity, and they give you 2 time periods. They go find the average velocity for the time period, and they give some a time period. Okay. Well, this is height, right? This is height. And they said, give me the average velocity. Well, average rate of change of function. Guess what is? What's the average rate of change of position? That is velocity. Do you follow me? So I think that's important just to know that. We're going to find the average rate of change of the position with respect to time. We're going to find the average rate of change of position, height, with respect to time, but there's another word for that. And you go, what is that? It's just called the what? The average velocity, right? It's average velocity, that's what we're finding. So this is all we gotta do. No, so all we gotta do is do f of b minus f of a over b minus a. All they do is just give us the time periods. Okay. So letter I, and this is why I want to do this problem with you, the way that it's described in the book may be confusing you. They go starting at time equal to 2 and lasting 0.5 seconds. So can I put that in other words? I need you to find the average velocity. This is height, right? Can you find the average velocity from t equals 2 to, how much further do we got to go? 0.5 seconds, so 2.5 seconds. Alright. Then you got to go from 2 seconds to 2.5 seconds. And just find the average velocity. Alright, let's do it. F of b minus f of a all over what? Everyone feel free to use your calculators if you want. F at 2.5 minus f at 2 all over 2.5 minus what? 2. But my rule of thumb is if 2 people get the same answer, then I know it's right. So if somebody else could double check that, that would be great. Now, if we don't get the same answers, then we'll go look at the calculators or how you computed it. These are some weird decimals, so you probably want to use technology on this problem. Because there's a part B and it leads to something. So this was actually letter A. Find the average velocity. This average rate of change in position with respect to time. So on average, everyone, how fast was this ball traveling? Don't be shocked if you get a negative answer too. Because everyone, can velocity be negative? Excellent. So when I threw that chalk going up on the board, well, up in the wall, up in the air there, that chalk, when it was going upward, it had positive velocity. When it was going downward, it had negative velocity. Cool. What do y'all get out of this? Anybody get an answer yet?
I got negative 32 feet per second.
Negative 32. Anybody else get that? Oh wait, let's see if anybody else gets this. I needed feet per second. This was feet, this was in seconds. Feet per second. Did anybody else get that? Thanks for doing it.
Yeah, negative 32.
That's it. So we got two people. That's how it always works. You get two people. No way two people can screw up the same way, right? You may say it's likely now. Usually in the class, people get the same answer. So that's it. So on average, the ball, how fast was it traveling? Negative 32 feet per second. Why is it negative? Well, during that time period, the ball was on the downward path. That's what's going on. It went up for in the first couple seconds, but then it started going down. All right, we get it. All right, well, what did they get to in letter B? They want you to do the same thing. So, and this problem may seem tedious to you, but there's meaning behind it. There's a reason why we want you to keep going through this. In letter B, they go from t equals 2 seconds to how much? 2.1 seconds. Now, do you notice this was tighter? Does someone say this? This was tighter? It was like a tighter region? Okay. So there's a reason why they're doing this. You're like, okay, I'll just go through the motions. There we go. Just do this, right? In fact, I think we'll skip D, C, and we'll just go down to D. We'll get down there. Alright, so that was negative 32 feet per second. Let's see what we get.
I have a question.
Oh, you bet.
So the negative velocity means that it's decelerating or something?
Nope. Well, so acceleration, we could talk about how with acceleration and velocity being negative and positive. The key was this, like pretend this was that object that got thrown. I'm just going to throw it up and down right now. I'll make sure it doesn't drop this time of break. When it was going on its downward path, it had negative velocity. And when it was traveling up, it had positive velocity. Now here's another thing. Do you know what the velocity was when it got right at the top?
Zero.
It was 0. It was exactly 0. There was an instant when that chalk reached its top height and it came back down. So it had, I threw it up, it had positive velocity, got to here about 0 velocity, came down negative velocity. Now some things, sometimes things move right and left. So when it moves to the right, positive velocity. When it moves back to the left, negative velocity. You can think of like an ant. An ant just crawling on this tray here. So like, all right, the ant went this way, positive velocity. What if it stopped? 0 velocity. What if it went that way? Negative velocity. Cool? Yeah. Hey, can we get this one?
Negative 25.6.
All right. Get that?
I got
What?
I
Oh,
got
2. That's 2. Hey, excellent. We got 2. We got it. Feet per second.
That's not what I got.
Oh, you got something different.
No, I might have done something weird.
Could be that calculator. Don't worry.
Yeah, it could be.
It's a little more tedious. That's how I grew up.
I got
Yeah,
negative
that-
32.
Oh, so it's definitely not going to be that because of how this was different.
Yeah.
That being a little bit tighter. So you can go back. You'll see where you are. It's probably one of these numbers in there. Did you divide by the 0.1 there?
Yeah.
Oh, good. Cool. It's probably in one of those 2 values that you got. Everyone, I'm going to skip to D now. C is just like this. Do you notice this got tighter? Closer time period. Closer. One more of these, and we'll see where we're going with this. This is the best introduction you can have to calculus. We just need one of these problems. Find the average velocity from 2 seconds to 2.01 seconds.
Oh, I know what I did.
You know what it was? What was it?
No, I know what I did wrong. I did all these wrong except for the first one being just. I don't know how I got
That's the best part though, you found out what your error was. And when they want you to find that average velocity. I mean, my goodness, that 2 seconds of 2.01 seconds, it's like, right? But this is what we're getting at. This is leading us into calculus. It's still an average velocity, just over such a tight what? Time frame. 0.01 seconds, right? But we're still going to get the average velocity of this ball that was thrown From 2 seconds to 2.1 seconds, right? This is the average velocity from t equals 2 seconds to t equal to 2.01 seconds. And we're looking at these numbers here and how they're kind of going. You have a feeling this is going to be negative? Yeah, me too. These last two were negative. It's probably negative. And when all they're doing is they're using technology just to go, what's f at 2.01? What's f at 2? At least we see the denominator is just a 0.0 what? 0.01, right? Good? Hey, what do y'all get?
Negative 24.16.
Negative 24.16.
I got that as well.
Awesome. So we get this. So this leads us to this. Are you ready? Welcome to calculus. Ewan, can you make an estimate now for me? These are all what kind of velocities? Average. Okay, yeah, average rate of change of position, average rate of change of a function, average rate of change of height with respect to time. These are all average velocities. Can you estimate the instantaneous velocity? That means at one instant, right? At exactly t equal to 2 seconds. But we're saying estimate because you haven't been taught how to do this yet perfectly. That's calculus. But this is what we're talking about. This takes calculus to solve this. But this should give us an idea. Because between 2 and 2.5 seconds, that's the average velocity. Between 2 and 2.1 seconds, that's the average velocity. My goodness, these are like on top of each other, right? This is very close to an instant, right? It came down to this. So if we had to estimate what would be the instantaneous velocity right at 2 seconds, what do you think you'd go? Which one of these answers is the best estimate? Is it that one? No, it's 2